Hello students, today we are going to go over 14.2a, exponential growth. And the objective is I can write a function that describes exponential situations. So we have some vocabulary here. Interest. Hopefully you've all heard of interest before, but it's money paid regularly at a particular rate for the use of money lent or invested. They say that if you understand interest, you earn it. And if you don't understand interest, you pay it. So would you rather be earning money or would you rather be paying money? So here's a little formula here. Interest equals principal, which is the amount of money loaned or the amount of money invested, times the rate. So this is the percent of interest charged to either loan you money or that you get as part of your interest rate, times the amount of time, depending on if it's per year or quarterly or semi-annually, and that'll be the total interest earned. Okay, so interest rate is the percent of the principal charged by the lender for the use of its money. Simple interest formula, a formula to calculate interest earned or charged on a loan. I equals PRT, where P is the principal, again the amount of money, R is the annual interest rate in decimal form, and T is the loan period expressed in years. Annually means every year. So Bianca invested $5,000. At the end of each year, she earned 13% interest. That interest was added to the amount in the account, and the money was reinvested for another year. This was done for a total of 5 years. How much money did she earn? So first of all, we want to put in the amount of money that she invested. So she invested $5,000. Okay, so how much did she earn in interest? Well, we put $5,000 times, and we changed 13% to decimal, 0.13, and that equals $650. So at the end of the year, she has the $5,000 and $5,650. So that's after year one. Year two comes around and she says, now I have $5,650 and I'm going to earn another 13% on that. So 5,650 times 0.13 equals $734.50. Okay, so at the end of year two, she has earned $6,384.50. Okay, so then the next year, she starts out having $6,384.50. And I think you can fill in the rest here. Okay, I took a screenshot of it finished, but maybe I'll put that at the very end here. But you would do this times 0.13 and get your amount. Okay, so can you imagine doing this for a 40-year loan? Mathematicians created an exponential equation that can complete this calculation easily. Okay, so we did an exponential one, and the formula for that is A, and that's the amount, equals little a times 1 plus r raised to the power of t. And I'm trying to remember how you do the little raised to the power. I don't know where it is on the keyboard here. So there it is, raised to the power of t. So t is time, r is interest rate, a is the amount of money, and I believe, big A is going to be the amount of interest earned. Okay, so I'm trying to move this. Okay, so A equals, little a equals the initial amount. R is the rate. I'm going to put interest rate. They kind of want to leave it just rate because interest is different than interest rate. So I'm going to put percent or decimal. So if they say it's 15%, you know it's 0.15. And T is time, and normally you do time in years. So if they say it's for 6 months, then you would put 0.5 for half a year. And the 1 represent 100% of the money invested. Okay. All right. So also 1 plus R is your growth factor. Okay. So the amount of money that you receive is equal to the initial amount that you invest times 1 plus R, so 1 plus your interest rate raised to the power of T. So remember, you get this raised to the power of T before you multiply by A because of order of operations. Okay, so now we're going to go on to the next page and do a few of the problems here. So if we do this same problem, but we don't want to do it every year, let's figure out what we would do here. So the A here equals $5,000. Okay. The R equals 13% or 0.13. Okay. And T is time, which is 5 years. Okay. So we put that in our formula. A equals 5,000 times 1 plus 0.13 raised to the power of 5. Okay, try that on your calculator first. Pause the video and see if you can get the same answer as I got. Okay, so the total amount should be $9,212.18. Okay. All right. So I think you can finish the rest of these. I'm trying to think. Again, with the exponential function, big A is the amount, little a is big A is going to be how much money you're going to have at the end. Little a is how much money you have in the beginning. R is your rate, and that's usually interest, and you'll keep that generally in decimal form, and the time is the amount of years. Okay, so I thought maybe we could do one other problem. Let's see, should we do cell phone subscribers? 1985, there were 285 cell phone subscribers. They increased by 75% per year after 1985. Find the number of subscribers in 2008. Okay, so what we want to do is we say that the amount equals, okay, how much in the beginning? 285. And we're going to say that is 1. We always have a 1 plus something. And we're going to say it increased by 75%. And it's raised to the power of, okay, let's go ahead and see if we can move this. Trying to move it around. Raised to the power of, okay, so from 1985 to 2008, if we do that, 2008 minus 1985, 15 plus 8, that equals 23 years. So back over here, we raise this to the power of 23, okay? So try and do that on the calculators. So this again would be a estimate for the number of subscribers in 2008. A lot of you students ask me, when are we going to ever use this in real life? Well, in companies, you want to be able to figure out like how many cell phones you need to make or how many subscribers are going to be out there. What is your projected income at that point? How many people are going to need to hire? So in business, this has a lot to do with business. Okay, so the final answer on that one would be 110,845,988. So do you think that's come to fruition? So that's how many people? Oh, we have to have our units, so that would be subscribers. Do you think there's that many people that subscribe to cell phone use? Okay. All right. Go ahead and finish the rest, students. I think you can do it. You rock.